Hello everyone, and welcome back to D&G. What I have for you today is the absolutely most peculiar, interesting, and unparalleled digital camera I've ever seen. This is the HP PhotoSmart 618, a point-and-shoot from the very, very early 2000s, and it would be completely ordinary and fly absolutely under the radar and have nothing unique about it at all if it was not for its software. Because the software and the operating system that it runs on in this camera is completely unparalleled. It hasn't been done ever since this camera. This is a deep dive into the HP PhotoSmart 618 and, on a larger scope, Flashpoint Digita, the operating system specifically for digital cameras. But before we get into that, just quick hardware look, just a look around the side. So of course, front of the camera looks extremely nice. It's far more composed and professional looking than most digital cameras in the 2000s were. Most manufacturers were trying to go for something crazy and wacky, going with the usually a transparent plastic style or some crazy curves thrown in there. They didn't look like cameras, but this looks like a nice film camera. And that's because instead of HP designing this camera, Pentax did. So Pentax did the optics, as you can see up there, Pentax zoom lens. Pentax did the optics and the design of the body, presumably, while HP wrote the software. So Pentax and HP combined their expertise in software and hardware. So our friends over in Europe and Asia knew this as the Pentax EL200, and there was also a Pentax EL2000, which was also sold as the HP PhotoSmart 912, with very similar hardware on the inside, but just a bigger body. Now, speaking of that body, we'll just do a quick look around the outside. So, on the front here are a ton of sensors. Up there are infrared transmitting and receiving LEDs, because this camera can wirelessly beam photos to printers and other cameras and your computer over IRDA or JetSend. There's your viewfinder, not through the lens obviously, flash, xenon, quite bright, nice and effective. Top has your mode selector switch between take pictures, look at them, and edit your photos, and connect to PC. And then here are just some simple function buttons up by that small LCD. You've got your flash on and off, self-timer, and focus far or near. Now, playing off the focus theme, another sensor which is up on this bar here is the focus sensor. Focus did not used to be metered through the lens. It was determined by often discrete sensors in cameras like this in the late 90s and early 2000s, and I'll talk about that in a bit. Now on to the back. This is of course where the interesting things are. So on the back here, that's where things get interesting. Screen and a ton of buttons and a speaker and microphone. Now I need to go on a tangent about this screen and how HP describes it really quickly. So, in the manual, HP does not list the resolution or the aspect ratio. They list the number of pixels, which is 130,338 individual pixels. Well, assuming this display is 4:3, it being a resolution of 400 by 300 pixels would get us to 120,000 pixels, so that's close. But it's too tall if it's 413 by, 310? And it's too small. There's not enough pixels if it's 412 by, 309? So, this screen is 312.8p. Obviously, that's not the actual resolution, but I would love to know what resolution it is. I don't just want to know how many pixels it has. Anyway, it is a 2-inch LCD, CCFL cold cathode backlit, so it chews through your damn battery, but those 130,338 pixels look just fine at 2 inches. They're not too grainy. Color accuracy is reasonable for a display this old and this small. It performs pretty well. Okay, that's the hardware overview, and we'll look at some photos later. But what I need to talk about first is the operating system. Now, every camera has an operating system. The one I'm shooting this on right now has an operating system. It has to, after all, something has to interpret the button presses and draw the user interface and allow you to select photos and transfer them to your computer. But the PhotoSmart 618's operating system works in a way that no other camera operating system before or after it ever has or probably ever will. That is because the PhotoSmart 618 runs an operating system known as Flashpoint Digita, or DigitaOS for short, developed and released by Flashpoint Technologies in the late 1990s and barely making it over the crest of the new millennium and only onto barely over 10 cameras before being discontinued. DigitaOS allows you to install your own software on your camera. If your camera doesn't satisfy your needs from the factory, you want some more photography modes, or perhaps, hell, even some video games, you can do that with DigitaOS. In fact, you can even write your own software for it. And that is truly what makes the HP PhotoSmart 618 and the few other cameras that run DigitaOS so unique. It's got a 2 megapixel sensor that's almost half frame in size, takes solid photos, Pentax optics, and its CPU is the most powerful out of all the CPUs that DigitaOS was released upon. Because DigitaOS, in addition to being like Windows or Linux or Mac OS or, computer operating systems where you can install software on them, it also was released on a pretty wide range of CPUs, and different camera manufacturers used it. Minolta, Kodak, HP all used Flashpoint Digita throughout several years and almost a dozen different models. And there were 3 CPUs, and RAM ranged from a couple megabytes to well into the double digits of megabytes. I believe this has 16 megabytes of RAM, which is outlandish for a camera. But anyway, out of the 3 CPUs, this has the Coldfire processor, the most powerful of them all. But the processors all have a common ancestor. They're all derived from the Motorola 68000 architecture. So no ARM CPUs here. No, it's basically just a crazy overclocked Motorola 68000, which is incredible. So this is a 16-bit processor that, went in game consoles, home computers, all that stuff in the 80s, and now it's finding its way into digital cameras 20 years later. But that's enough talking. Let's turn it on and play around with this operating system a bit. Powering on the camera briefly shows the DigitaOS operating system logo along with HP's. Now let's delve into the capabilities of Digita. So here's the menu system, and the first section to come up is capture settings. So that's where you can change your photo resolution and all of that. And also for time-lapse mode, you can change how many pictures the camera takes over what interval between 15 seconds and 24 hours. But here are all of your photo settings, and this is absolutely fantastic to see on an early 2000s / late 90s point and shoot, because none of these settings, except for sometimes exposure compensation, are on most point and shoots from this era. Exposure, of course, just gives you some presets. You can't precisely tune anything, but there's a solid number of presets. EV compensation lets you go from between 0, of course, and -2 and +2. White balance, again, gives you some presets. You can't set it in, K values, like 6500, 5500. Focus, again, manual focus, I'll turn that on and get back to that in a minute. AE metering, that's spot, center, or average, and ISO speed, you can actually set the ISO, although there are only two settings, 100 and 200. Now, before we go further into the menus, let's talk about that manual focus, the value of which is indicated up at the top left of the display. Now, it can't be precisely adjusted because it is digital manual focus, and these are actually the values that the camera sets itself to when it is doing autofocus, but now you can just manually cycle through those. So it's not like autofocus is more precise, it's the same intervals, to be clear. So you can go from 0.1 meter, 0.2, 0.3, that's pretty precise, but then you're up to 0.5, 0.7, 1, 1.5, 3, so there's a bit of a jump here, although it's not too terrible. Then you go from 3 to 10, 10 to infinity. So you get a pretty wide range of focus lengths, but the jump, especially from 3 to 10 to infinity, is a little bit large. Down here you can change your shooting mode, one shot, continuous, or time lapse. Continuous is you hold the shutter button down and it takes a burst of photos. Overlay, that just turns off the little live preview. And status, that shows the quality you're shooting in, your battery, and just some other information about the camera. Let's head back to that menu system. You can set a timestamp, of course. This is your system preferences. There's a lot of things you can change here, but none of that is interesting. This is what is interesting. This is software that I have put on my camera. So, from the shooting mode, I can access DigitaOS scripts. There are two variants of DigitaOS software, scripts and programs. This is a script. It is a plain text file, and you can write it yourself. The camera compiles and interprets its commands on the fly. This is a software that I've written to help me write other software. So we'll go down here, I'll set the menu timeout to 5 seconds. This only took me a few hours to learn the language and write it. It's a fun little pseudocode language, but this will just tell you everything the camera knows about itself. The camera stores all of this information in ROM. It tells you its hardware revision, it'll tell you how many photos it's shot, it'll tell you how many of those with flash it's shot. So we've shot 13137, that's a fun number. Let's see, it'll tell you your serial number. How about free RAM? How much do we have? Yep, that's 12 megabytes of free RAM. So that's a ludicrous amount of RAM for a camera, and that's of course because this can run your own software. So it needs more RAM than a standard camera. Flash photos, how many has it taken? 2133 with flash. So the camera knows a remarkable amount of stuff with its about itself, and this is just a software that lists that all out. So the camera knows a lot about itself, and there are commands within the Digita script that let you probe the file system of the internal camera ROM, not the compact flash card, where the camera stores this information, and this software just finds those and prints them out. Now, this is an example of a software that is practically useful. Ruler Mark II. Now, I didn't write this software, I simply ported it to the HP PhotoSmart line because the original creator only made it work on the Kodak DC260 and 290, but it works just fine on the PhotoSmart 618 when the version check is removed because they have the same autofocus capabilities. So we'll do distance to object. And so what this does is, I'll just take a picture of my printer, which is about 4 feet away. Takes a flash photo of your object, processes it, and it finds the focal length in metadata that it was shot at. Yep, 4 feet. It finds the focal length in metadata that the autofocus sensor recorded, and then it tells you how many feet away the object is. Now, of course, this is not great I'm going to take a picture of a lamp on the other side of my room. This is not great because, as you saw, the autofocus is in somewhat coarse intervals with jumps of half a meter or more sometimes, and it'll give you results like 215 feet away. So it is fallible, but it is a really, really cool example of what one can do with a camera that can run its own software. Yeah, 215 feet. So it's not perfect by any means. When you switch to review mode and hit menu, you get your image settings, but then you go further, and that's when things get fun. Those are your programs. So to run a program, you can't just launch it. The camera actually fully shuts down, and the next time it boots up, instead of loading DigitaOS, it loads your program. This saves RAM, of course. So, because it has a screen and buttons, someone has ported Doom to the HP PhotoSmart 618 camera. Unfortunately, there is no sound on the PhotoSmart series. There are some Kodak cameras that can play Doom with sound. So, it's like one of your, it's the zoom out button. It's the telephoto button that's shoot. You move with the arrow keys, of course, and it runs very, very well. Now, this port was not difficult because this is a 16-bit processor, so there's no conversion of any sort that needs to be done. It's just a regular old 16-bit processor. Like, this is not an ARM CPU. It's a glorified Motorola 68000. Now, this camera has an AV video output. You can get composite video straight out of this camera, and composite video replaces anything that's on the screen. That includes Doom. So you can, in fact, use the PhotoSmart 618 as a plug-and-play video game console. And here's some captured footage of the 618 running some Doom. And while that's playing, I'll talk a bit more about the software. So, to write software for DigitaOS, you can go two routes. One of them is the very easy one. The scripts, they're compiled on the fly, as I mentioned, and you write them as a plain text file. I used the word pseudocode earlier to describe it, and that's what it is. I'm not a coder, I don't do programming, so I can't really say what programming language it's similar to, so I'll just spell out what it's like to use it. There is a set of commands you can probe the camera with, and those are things like get photo count, or you can set your ISO, you can set your exposure, you can set time lapse. But on top of the camera usage, the scripting can also perform file management functions. It can move and delete files, it can probe your system folders, it can probe the camera's ROM, as you just saw. Now, the graphical user interface for scripts, you don't make that yourself. You use commands to create a list that the Digita operating system displays. So, if I were to write another software that was to be like lists of my favorite ice cream flavors, it would look the same as that program I showed you that lists the camera ROM information, because the way the menus are laid out would be the same. Now, it can also do simple arithmetic, and when I say simple arithmetic, I mean simple arithmetic. It cannot comprehend negative numbers, it cannot comprehend decimals or fractions, and I will mention that a problem I've run into with this camera is with the clock. Interfacing with the clock is stupid and it sucks and I hate it, because there's a mismatch between number formats between the clock and Digita script. So, let's type in 20 on our TI programmer calculator that allows real-time conversion between decimal and hexadecimal. So, this is 20 in decimal notation. You convert that to hex, and you get 14. I was wondering why when I set the clock to count for 20 seconds, it would count for about a quarter of a minute. And that's why. You have to take this into account when you're writing scripts. So let's say you want you want some interval to be 60 seconds. Then when you convert that to hex, 3C. Oh wait. Variables have to be declared as a number or a letter. Or a string, that is. An integer or a string. Integer makes sense why there aren't any decimals. String means it has to be letters. And arguments for commands require one of the two, and you can't switch them up. So let's say the shutter count. You want to pull the shutter count of the camera. You can't tell DigitaScript to store that value as a string. It has to be stored as an integer. So that means when you get the clock value, and the clock value comes out as hexadecimal, which has both letters and numbers in it, you can't do very much with it, because in DigitaScript you cannot declare it as an integer because it has letters in it, but if you declare it as a string, then your software, your script, won't be able to recognize that it's a number and use the number of seconds elapsed since you last pulled the clock to determine the actual passage of time. I'm not making this point very clearly, but just your takeaway should be that the clock is very convoluted because it's stored in hex for some reason and DigitaScript can't process that. So that's my only big complaint, and it is something that will never be fixed. Let's get on to what this is built for, though. It's built for photos. It's built to take pictures, and it does that very well with its 3x Pentax designed optical zoom and its pretty solid CCD sensor that's nearly half frame, a little over 2 megapixels. Takes some pretty solid photos for the time period and some nice nostalgic photos today. Now, it takes a compact flash card. It will not take a 4 gigabyte card. It will, I think, take a 2 gigabyte card. Cannot take an IBM micro drive. It uses too much power, the camera won't spin it up. A 1 gigabyte card will give you 999 photos on the largest, highest quality setting. Each photo is a tiny little baby bit over a megabyte. My favorite feature of this camera is time-lapse, because I've never had a camera that can do time-lapse, so I'm going to show you some wonderful time-lapses I've shot. Whether that be a long sequence or setting up a camera and waiting for something cool to happen, it's a medium I've never experimented with before the PhotoSmart 618, and now that I have it, I've been playing with it endlessly. As far as other photos go, it's predictable for a 2000s camera. It can look a little washed out in very bright outdoor settings or when the flash is used in a small space. Its low light performance is poor because it is a 2000s camera with a CCD. Although overall, its performance did pleasantly surprise me. It takes good photos. This really genuinely takes good photos. The manual focus mode, although not the most precise, does make getting up close and personal with either subjects or objects work out pretty well. It takes great landscape photos, of course, and the time-lapse mode is fascinating, but of course the best aspect of this camera is the software. The fact that this camera can run Doom. The fact that me, an idiot, can write software for a camera. The fact anyone that doesn't work at the camera company can write software for their camera is such a fascinating idea that just has not been explored ever since DigitaOS. So that's gonna wrap it up for this video. I hope you like my new camera, as in that one, the one that I'm filming on. It has fancy features such as autofocus and video that looks half decent. So I hope you like that camera, and I hope you liked this camera. So please do give me feedback on each. Now here's a spoiler, I'll be covering some more DigitaOS cameras soon because I've fallen down the rabbit hole. So if you're interested in that, stay tuned. But that's it for this one, so thank you so much for watching. Hope you enjoyed, and I hope to see you next time.